Hello and Assalamu alaikum. Hope you all are doing well. So today we will be talking about work, power and energy. First of all, we should know that what work is. So the dot product of force and displacement is called work. It is the simple definition of work that the dot product of force and displacement is called work. After that, as we all know that work is equal to force into displacement. When we are removing this dot, so we are having cos theta. Okay, so we can say that force is equal to fd cos theta, and work is equal to fd cos theta. After that, what we are having, we have taken out the SI unit of work. F means force as a unit is Newton and displacement as a unit is meter. Work is equal to Newton meter, and Newton meter is equal to joule. Work is equal to joule. So the dimension of work in W is equal to F dot D is uh, we will write as it is the dimension of F, as we all know that the dimension of F is MLT minus 2, and remaining dimension of D is L. Dimension of D is L. So we will merge it and write here W is equal to ML to T minus 2. So T minus 2 is the T minus 2 is ML to T minus 2. We are having a work. After that, work depend upon the three factors. What those three factors are? Number one is work depend on force. Work depend on force, displacement and angle. These are the main three factors of work that work depend upon three factors: force, displacement and angle. Now we should know the concept of dot product and cross product. Actual what dot product and cross product is, that dot product is vector dot vector into dot vector is equal to a scalar. So this is called a dot product whenever the multiplication of dot sign. Okay, and the cross product whenever the multiplication of cross sign, so it will be the cross product. Dot product always is a scalar and cross product always a vector. Okay, so after that, dot product scalar and have a cos theta sign, and after that we are having sign of sin theta. Sin theta will every time come in a cross product. Okay, and dot product and cos theta used for work, and cross product and sin theta used for torque. Okay, now move further. Now we should know the theta, or we should know the angle, that how angle works. Now the simple we have to remember or memorize that whenever we are having theta 0, so we are having 1, work would be maximum. Whenever we are having theta 90 degree, so the angle should be 0, and we will put 0 with the cos theta 90. With theta 180 we are having -1, you can say negative. With theta 270 we are again having 0, and you will put 0 over here. With theta 360, whenever theta 360 will be there, we are having half, you can say 1 upon 2. What you can say 1 upon 2 we are using for theta 160. Now I have put some examples for you guys over here, that we are having this one example, that W is equal to F dot D cos theta. So F, suppose that force we are having 10 and displacement we are having 100. Okay, and then cos theta 0 is equal to 1, work maximum is 1, so we will put 1 and our answer will be work is equal to 1000 joule. Same as all this one, same as all I have done this one, these all are done by the same method. Okay, hope you all understood this one. Now let's move further with this. Now we should know the concept of our concept of work done by a constant force, and second is work done by a variable force. Now firstly we will be doing work done by a constant force. So work done by a constant force, let's suppose just wait. Okay, I hope that now you can see it easily. Okay, so let's suppose we are having we are having any kind of a block. Here person is standing from A to B point. If the force will be same constant, so the displacement will be also that much. How much force will be? We are having that much, you can say we are having that much constant too. Okay, I should put it over here. Now let's move further, do one example. Likewise, just wait, I should erase this one. Okay, now let's move further. As we are having here force 5 Newton, displacement 5 meter, theta 0. As I told you that whenever theta 0 will come, we will put 1. So work is equal to 5, displacement is equal to 5, cos 0 is equal to theta is equal to 0 is equal to 1. So our answer will be work is equal to 25 joule. Okay, now as we have done over here in a graph position, force will remain same. In constant force, work done by constant force, angle will remain same and displacement will remain same. How? So we should know that how. Firstly I should erase this. Oh, what happens? Okay, now let's move further. Like this is a F, this is F, and this is D. Okay, F and D. Force is in a vertical position, displacement in a horizontal position. Now what we have to do, like we are having 5 Newton force, so we will start from here. 5 Newton force, 1 meter, then force will remain constant, then 2 meter, force will remain constant, then 3 meter, force will remain constant, 4 meter, force will remain constant, displacement 5 meter. So work done by a constant force, work in which force does not change, remains constant, but displacement increases, is called constant force. What it is called? Is called constant force. Now let's move further. If we are having graph in this one position, so what we will do? We will do that we will add the displacement first and divide it by 2. Now we will add, like we are having 4 and 9. These are the two ending points. We have added this is the formula, and divided by 2, and displacement will remain same, force will remain same as we are having 4 6, so multiply by 6. So 4 plus 9 13, 2 will remain same, then 2 1 are 2, 2 3 are 6. Wait, I should do over here 13 upon 2 multiply by 6, then 2 1 are 2, 2 3 are 6, then 13 3 are 39 joule work. Okay, 39 joule work. Now if we are having more positions of graph, like if we are having graph in this one position, so what we will do? It's a simple method that if the graph is in this one position, you will count its force from here and displacement from here. Like we are having so here we will be the here we will put the formula of 1 work is equal to 1 upon 2 force dot displacement. This is the formula to find this one graph. Okay, so as suppose that we are having force of 10 Newton and displacement is 5 meter. So 1 upon 2 multiplied by 10 into 5. So 2 ones are 2, 2 5s are 10. We are having 5 5s are 25 joule. What will be remain? Work is equal to 25 joule. So we can easily find in this one way. Now last we are having work done by a variable force. Now how we can find the work done by a variable force? Previously we have done with a constant force. Now variable force, it means that the force cannot be changed. Okay, so firstly we should read a I should read a definition that in which force, displacement and angle change its position is called variable force. What it will be called? It called variable force. Now let's move further with this one, like force, displacement and theta, how it will be changed. So I will make one diagram, with that you can easily understood. So like we are having, I am making this. Okay, this is a 1 point, the second point. Now here force is changing, displacement is changing, theta is also changing. How is it all changing? Wait, you should know that. Now just concentrate over here that how it's changed. Like if the force is going in this one position, okay, so the displacement is going here. Okay, this is a D, you can say D1, this is F1. Okay, and the theta is making a different angle. Okay, now likewise if it's going in this one position, okay, this is F2. Okay, give them a name of F2. Then displacement is changing its position, so it's D2. And theta will also change. So again and again it's changing its positions. So how we can focus on it, how we can do it? Yeah, there's a one more solution. Like if I made this one now, like for the variable force, so what you have to do, you have to cut into a parts, like 1, like 2, like 3 and 4. You should give a name to them, like W1, W2, we are having then W3, and you can say so on. Okay, now let's move to the mathematical side. How we can add this all and calculate? So we will calculate it by uh, cut in the positions, and like we are having this one formula, that W is equal to W1, W2, W3, this all, and then so on. We will add this all. So W is equal to F1 D1 cos theta 1, F2 D2 cos theta 2, F3 D3 cos theta 3, and so on. If we are adding this one, so if we are having more than 100, so what we will do? What we will do over here? So what we have to do here, that now it's not easy for us if we are having 100. So what we will do? So there's one more solution over here. This is that one solution. That, wait, I think I have written a wrong spell over here. The spell is summation. Summation. Okay, now this sign is called the summation sign. This sign is used to add the large values, and this sign is an integration sign. This sign used to add small values, like there is too many small values that are in a points. So these values we can add by the integration method. What we will do, we are having here, now you can easily see that here, that we are having W is equal to summation f d cos theta. As I have mentioned over here, that n is equal to number, I is equal to integer. We will write integer over here. How many integers? Like we are having 1 to 100, so we will write here 1, and here's n total numbers 200. So we can easily add over here like this method. Like if we are having 3, so we like n number is equal to 3, and number total number over here, then f d cos theta with every number. Okay, this is a method for the adding large values. What method we will use for adding small values? That we will put the sign of integration. Here we are having a portion and b portion after the fds. and ds means that to find the small displacement we have to use the integration sign. So hope today you have understood and enjoy a lot that today we have done our work done by a variable force, work done by a variable force. After that we have done our work done by a constant force. We have done today we have done our theta one. We have done work, power and energy. We have started from here and we have learned about work, power and energy, that what it is actually. After that we are having done with theta, and we have done constant force and variable force. Hope you all understood. Thank you so much.